Hello guys, how are you? So today I'm going to discuss with you some very important basic concepts from the basics to the advanced level. Means what should you know mostly related to the data science. Means if you want to become a capable data science, or if you are trying to switch in your company, or you want to change your roles as per the current situations, then you should know do some basic questions, and you should definitely know their answers, and based upon that definitely we're going to learn all those things. So I'm going to tell you some important concepts, and what should you know. So initially you should know basic of python from basic to the advanced one, and after that you should know that leaks dictionary, file folder handling in python, how you are creating apis, and little bit about the data structures. So after that Python, you should be focused on the machine learning, and in that machine learning, you should know the all those basics to the advanced level differences, such as what is supervised machine learning, unsupervised machine learning, their algorithms, their hyperparameters, and all those. And you should know also the basic principle how each algorithm is different from another one, and how they are evaluated, means evolved from one to the advanced one. And I'm going to give you some questions. So please try to get the answers, or try to find the answers, or you can also write down those answers in the comment box. And those are the some specific questions, such as you should know the basic difference upon supervised and supervised, and reinforcement machine learning, and why we require some particulars of those machine learning algorithms. And before that, how you are doing the data pre-processing, how you are handling nan values, null values, how you are replacing those values, and how you are selecting the features. There are various features methods, such as forward feature selection, backward feature selection. Then what is region lasso regularizations, or variant regularization techniques, and how you are utilizing, and what is the difference between region lasso, which drops the features or which reduces the value, what is overfitting, what is underfitting, when you have faced those challenges, and when how to means tackle those challenges. And apart from that, there are so many questions, but those are I'm telling. What is principal component analysis, and what is gradient descents, what is slow, what is bias, what is variance, and some various very simple statistical terms like mean, mode, median, variance, and probability, Bayesian theorem of probability. Means those questions are very simple, but if you are whenever you are trying to explain at that time, you are not going to able to explain all this in a simple manner. The difference between bagging and boosting algorithm, random forest, its hyperparameter, it gives us its hyperparameter, then decision tree, when to is which one, logistic regression, then odd ratio, and how those equations derivations are derived, and what is r2 square, r2 square, r2 square, and all those. Means we should know the all those log or loss functions. Like for classification report, there is a precision recall, like f1 score, then accuracy, precision recall. You should able to explain with their formula, with their definition, while drawing the chart or table. You should must be able to explain what is precision recall, and when should you are utilizing, what is harmonic mean, means why you are utilizing it for score 5, you are just choosing the harmonic mean and not other arithmetic mean or other type of mean. And if you are done this in this way, I think you may be able to, means it shows that you have sufficient grasp of those concepts. And after that, you may be further move towards the deep learning, where you should know all those, what is neuron perceptrons, how those neurons are linked to each others, what is hidden layer, input layer, output layer, and which layer contains what. Because there may be some input layers which just contains the neurons, and in the hidden layer there are weight and biases updations happens, and at the output layer there is a neuron with the just activation functions. So if there is a binary classification, then you can utilize softmax, but not softmax, it's a sigmoid function. But if it's multi classification, then utilize sigmoid. what is softmax sigmoid function, their derivations, and 5, we should use those functions, and you should always try to explain the importance of those functions. And you must also know about that, what we can say, that activation functions like relu, prelu, leaky relu, and all those relu functions, and how those functions are coming into the pictures, and what are the theory behind them. And apart from that, you should also know the how those gradient descents working, like stochastic gradient descent, batch gradient descent, mini batch gradient descents, then Adam optimizer, then root mean square propagation, means RMS propagation. Then another one is the adagrad. So you should know the differences between them, and how they are different from gradient descents, and how they have improved all those neural networks. And after that, you should know what is momentum with uh, its learning rate, how learning rate is changing, then decaying moment learning rate, then how Adam is controlling their learning rate, how it is learning safely, means by its own self, how you should initially increase the weight, and after that utilize the weight decay parameters and all those. So you should know all those concepts very well. And yeah, once you have done this, then there are some kernel weight and bias initializers like Gaussian kernel. Then there are other types of kernels, Hay uniform kernels, then normal uniform kernels. So you should know all those kernels very well. And yeah, once you have done, then you should also know the overfitting, underfitting in the deep learning. Then what is dropout rate, how you are doing normalizations, and batch normalization, how it will affect the neural network, then number of epochs, what's the difference between epoch and iteration, and fair to stop, and all those. So how you are utilizing Keras, or how utilizing TensorFlow, and which one is better, and how you are doing the hyperparameter tuning for deep learning and neural networks. So that's why it's also very very important, and we should know the basic theory behind all those functions. Once you have done this, then your next part is coming towards the RNN, recurrent neural network, then LSTM, large short-term memory network, bidirectional LSTM. Then maybe you need to learn about that CNN, that convolution neural network, and all those. After that, it can be get a recurrent unit and all those for embeddings from large language models. And at the last, there is come the transformer. So nowadays, a lot of focus is happening, becoming on the transformer. So before transformer, you should know all those NLP basic concepts, like how you are taking text data, how you are cleaning, what is lemmatization, what is stemming, their types, like portrait stemmer, the stemming stemmer, which one is the good, which has the best results, then how you are doing the lower casing of those characters and handling all those characters, which machine learning algorithms you are utilizing while doing all those. Like most of the times, it's an is preferred, or what we can say, support vector machine is preferred. There are so many classes, then random forest is also preferred. Then for NLP related, you should know, or you should have hands-on experience related to projects such as for NLP related, you should know, or you should have hands-on experience related to projects such as sentiment analysis, name entity recognition, question answer formatting, then summarization, then so many means picking some random words or some important words like keyword, phrase extractions, and all those. And after that, you should must learn the recurrent neural network, how it is different from that artificial neural network, as we have seen previously. How the hidden states are maintained, how the outputs of previous hidden states is given to the next level model, and what are its drawbacks. Then LSTM came into the pictures. How why LSTM is better than the recurrent neural network, and how its cell structure is actually increasing its memory. Then their types, what types of gates, how information is fed into the that LSTM, input gate, forget gate, output gate. Input gate continues that sigmoid function. forget gets also containing similar functions and output get containing terrace functions. So how those information syntax are given. Then I forget that's one very important part is that how embeddings are created in the NLP. So NLP is mostly related to embeddings and how you are utilizing. So there are some basic embeddings like initially we just utilizing that label encoder, one hot encoder to just convert the sparse matrix. But after that, there came the very important metrics such as TF, IDF, word vector, glow, and count vectorizer. You should know what is the difference, how their working mechanism, what are their drawbacks like out of vocabularies, which is better for the semantic relationships and which is not better. And once you have got that clear understanding, still they have so many drawbacks. Then we create the embedding by using Keras or LSTM's networks, and still they have drawbacks. Then at the last we shift toward the transformer models, and they utilize the some tokenizers like word-based tokenizers utilized by BERT model. Then byte pair encoding utilized by GPT models. Then latestly Google has just published one model. It's Gemma, and it's utilizing JMA tokenizers, and there are so many advantages, but those are the basic one, and you should know the basic difference. And you should know the exactly difference between LSTM and transformer. What is their difference? Like LSTM taking all the data sequentially, bidirectional LSTM taking data from the both the directions, but in the transformer we are not passing the data sequentially. We are just passing the data as per whatever the max lengths at a time parallelly. So transformer has so many advantages. It's doing all those data parallelly processing, but it has also limitations. Then another important question is coming how that positions of words is maintained in the transformer model. So for that, basically we are utilizing positional encoding in transformer. So, and they may be asked how that positional encoding is maintained. So based upon the sine and cosine sinusoidal curve functions, based upon the how much you are taking dimension, sequence, lengths, and vocabulary size. Based upon that, those words position is given to the transformer. And transformers are very based. They are doing parallel processing. They are creating multi-head attentions. Initially, they are creating head attentions like key query values, and based upon that, they are creating multi-head attentions. And based upon your specific task area, you have just need to upload some specific top layers on the already fine-tuned models. Suppose if you are utilizing, if you want to do the name entry recognition and you want to do the fine-tuning of any BERT model, so you just need to import that BERT model from transformer library, and you have just need to import some token classification layer, and after that you have just need to do the fine-tuning of those token classification layer based means on the top of that BERT based model. And for that you have need to create those training data. Then you should know how you have created training data, and how you have evaluated model, what is the size. Then you should know the BERT model, its working principle. Is it just based upon the encoder part or decoder part? Then what is the difference between encoder decoder? What are the similarities? When to use which one? And their business use cases. You should know their layer mechanism, how many it has sequence lengths, then their limitations, their dimensions. Same for the decoder models and same for the encoder decoder models. And you should also able to do the fine tuning of model by using that LoRa, low adaptive rank methods or pipped parameter efficient fine tuning. Then quantize LoRa to lower that memory and all those. And the most important is how you are evaluating all those models once you have created all those training data and all those. So you should know all those concepts very clearly. And if you don't know, then you are definitely going to face issue while working. But definitely if you are doing as practice, or if you are doing all your projects in the organizations, but those are the difference from those LLMs, or those projects are just based upon the traditional methods, then try to learn. There are so many articles, blogs, youtubers, or you can learn from those courses also. And definitely it will going to enrich your knowledge, because that is the very most important things. And once you have done all those transforms, then there is another concept scheme, and it's the lang chain. So why we require the line chains? What is the RAG, retrofragment resolution systems? What are the drawbacks of large language models like GPT, Llama, or Mistral? And why we need that RAG system? Then what are the vector stores? Why we require them? How we are connecting our data to the vector stores? How we are retrieving data? What are the various similarity metrics? And so many questions are there. And but those are the very very simple and easy if you do the thorough practice, and if you're doing a project side by side, then you will definitely get all those knowledge very nicely. So but you should know the answer of all those questions and your concept should be clear. Some important part about LangChains, like what are the agents, why we require those agents, how to improve LangChain. Then what is hybrid search, keyword search, similarity search, cosine similarity, vector stores, various types of chains using the languages like conversation chain, semi-chain, or just retrieval simple chain. And you should also know the drawbacks of each LLM. So are their costs like GPT 3.5 turbo model or GPT 4 models, their token limits, their context limits, and which one is the better model. So there are endless questions, but those are the very, very simple basic one. And if you learn all those, then definitely will get those questions also very well. And you will not be able to face any difficulty. Still, I have lived with the computer vision parts like CNN, then yellow models. You look only once they have 8 versions. Then R, RCNN and R mask and all those. So I will come towards that part, but just I have just now I have covered these some important questions and parts like machine learning, deep learning, large language models, languages, their evolution mechanisms, and all those. So whatever questions I have discussed, if you want to give the answer, please give me in the comments or just try to rethink. Or if you don't know answer of any of those questions, or if you are facing the difficulties related to any particular concept, just to go towards Google and search those answers, or try to find any tool or any courses, and you will definitely learn all those. So that's for today, and yeah, thank you. Bye bye. Have a nice day. Please learn, share your learning, and be happy.